Welcome to day 8. So far, our services communicate synchronously using gRPC. This is fast, but it has a fatal flaw, which is tight coupling. Imagine a user places an order, and the order service calls the inventory service to reserve the item. But what if the inventory service is down? The whole request fails and you lose a sale. So today, we're going to fix this by shifting to an event-driven architecture. We are going to introduce a message broker called RabbitMQ. Now, the order service will simply drop a message into a queue saying an order has been placed and instantly return a success response to the user. It doesn't care if the inventory service is busy, whether the inventory service is down, or if it is sleeping. The broker holds the message safely until it can be processed. We need to add the broker to our infrastructure. We don't need to write this from scratch. We just pull the official RabbitMQ image into our Docker Compose file. And of course, we are going to specifically use the management tag. This will give us a beautiful built-in web dashboard so we can physically see our messages moving between microservices. So go to the compose.yaml. Then just before traffic, I will hit tab, okay, and have RabbitMQ as the service. And I like the autocomplete by AI. I'll simply hit tab and explain. So like I told you, the image will be RabbitMQ with the management tag. And then the container name will simply be RabbitMQ. Then the ports 5672 will be the core port services used to communicate. Then 15672 will be the web dashboard port. Then for environment variables, we have RabbitMQ default user equals to guest, RabbitMQ default pass equals to guest. Simply the username and password having the same value. But of course, in production, again, like I tell you, pick this from your environment variables and keep it a secret. Next, we need a service to actually send these messages. Let's scaffold our third microservice, which will be the order service. We shall initialize it with UV like arrays and install FastAPI. But to talk to the RabbitMQ asynchronously in Python, we shall also need an amazing library called AIO Picker. This package will allow FastAPI to publish messages to the broker without blocking the main web server thread. Now open your terminal at the root of the project and run the following commands. So I'll clear my terminal and I'll say uv init --app services / order - service and hit enter. Then we're going to add dependencies. I'll clear the terminal one more time and say uv add FastAPI IO picker space -- package services / I don't need to put that services. I can only say order service. Okay. No need to do the services / order service. Okay. Maybe I'm tired. Let's find out. Okay. And by installing FastAPI, of course, I expect that UVCon will be added. So let's give it some time. Okay, looks like it's done. If you go to the order service by project.toml, you can see, yeah, the IO picker and FastAPI. So we are slowly growing out this project. Trust me, in a few videos from now, you will see how something small like this can quickly become big. But I think I should have installed FastAPI standard instead of FastAPI. So let me go to the order service, okay, and remove FastAPI. Then I think I did something similar for the root. I see we have FastAPI. I want FastAPI standard, okay? Just like they do it in the official documentation. So I'll clear my screen, and instead of add FastAPI, I'll say add FastAPI standard, okay? Say not found, I have to use quotes. So I'll put 2 quotes there. Okay, and of course, IOPIC has already been installed, so no need to reinstall it again. And UV will handle that for us. So if you check, you see we have FastAPI standard. And I want to do the same for the root pipe project. I'll simply say UV add FastAPI standard. Okay, I hope I'm not messing up things. Otherwise, I could cry a lot. So if you look at the root pipe project.toml, we have FastAPI standard. So, okay, looking good so far. Let's move ahead. Inside our order service, we're going to create our FastAPI app, and we shall use FastAPI's lifespan event to establish a persistent connection to RabbitMQ the moment the service starts. Then after that, we shall create a simple post endpoint to help us place an order. And instead of writing to a database, today this endpoint simply formats the order data as JSON and then publishes it to a RabbitMQ queue called order events. And then the moment it hits the queue, we return a success response to the user. So go to the main.py file in order service and paste this code. So at the top, you'll see we have JSON, async context manager, FastAPI, AIO picker, and then we have a RabbitMQ global variable. Then this is the lifespan I was talking about, wrapped with the async context manager, and we have global RabbitMQ connection. So in the comment section, tell me, what does global mean in Python? Then after that, we have the connection by saying await AIO picker.connect robust. Then we connect to RabbitMQ. As simple as that on port 5672. And then I'll simply have a print statement saying connected. Okay. Then we yield. After yielding, we have the cleanup. Okay. We simply close the connection, which is a very good best practice. Then we pass the lifespan as an argument to this lifespan parameter to the FastAPI instantiation. Then we have a path operation, and the path operation function says place order, takes in the product ID and user ID. Then we simply create the order event, which is a dictionary having the event, the product ID, the user ID, and the status. Then when we're done, we publish that to RabbitMQ. And using an asynchronous with context, okay, we say RabbitMQ connection dot channel, okay. Then using the channel variable, on line 33, we first avoid using the channel variable, not avoid it, but we first create the message, okay, by using the IO picker dot message method, and have the body having a value of JSON.dumps, okay, and it's simply doing a JSON.dumps of our event, okay, and then we call the encode method. After that, we can now say await channel.defaultExchange.publish, okay, then we publish this message, and the routing key, which is the queue name, is called order events. This is what I mentioned in the intro. After that, because this is of course asynchronous, we return an instant message saying message, your order received and is being processed in the background. To make this work in our cluster, we need a quick Docker file for the order service. And of course, we need to add it to our Docker compose file. So I will go to the order service and create a Docker file and paste this. Okay, it has the usual stuff that I've talked about from the very beginning. In case there's anything that looks unfamiliar to you, please let me know. But this is the usual stuff we've been doing. Okay, so if you've missed this and this looks maybe confusing to you, please check the previous videos in this playlist. You'll find that you'll understand this very easily. Okay, next up is the compose.yaml. Here, I'm going to add the order service. Maybe I should just put it at the end next to the other custom services we created. Okay, just after the product service. Okay, so we have the order service, the build, context, meaning the current location of the Docker compose file is in the current working directory. And then we have the Docker file. Okay, and this is simply mentioning where it's located. Then we have the ports. Okay, and we are exposing it directly to the for testing purposes. Okay, but we can have this also managed by our API gateway. Then notice we have depends on RabbitMQ. Can you guess why we have that? So that it doesn't try to connect before the broker is completely booted up. That's the reason, nothing else. So you see, all these things are very simple. So now run docker compose app -- build and wait for it to patiently pull RabbitMQ. It says manifest for RabbitMQ3 management not found. Okay, so this could mean I have to change. I allowed AI to guide me. But if you look at this, it says 3 management upline. It's supposed to be Alpine. Okay. All right. So sorry, should have done a quick review. Let's give it another shot. Be patient. It's pulling. All right. Looks like we have RabbitMQ up. I'll go to the browser and then try to check out localhost 8, not 8, but 15672. And there we are with RabbitMQ. So log in with guest and then guest and click login. Okay, no need to save the password. Okay, looks like, yeah, it's simply empty. Okay, I don't see anything here. Okay, this is empty. So what I need to do is to go to Swagger. Okay, refresh Swagger. We need that orders endpoint, but I'm not seeing that endpoint here. I think I understand why it's not showing up here, and that is because of traffic. We don't have the orders endpoint in the traffic labels. If you see, the user service has those labels. So for the order service, I would need to do something like that. Okay, but it's okay. Let's now go to the browser. Okay, I can skip this and go to localhost port 828. Was it 82? No, it was 8002, then /docs. Okay, and it says it cannot be reached. Interesting. So it looks like there is no shortcut and I have to configure traffic. No problem. Let's see what we can do. I figured out the issue, and it was because the order service was crashing out, and this was as a result of RabbitMQ not being ready. So on the order service, I add this condition, okay, that RabbitMQ should be healthy before the order service can be executed. Then on the order service, rather RabbitMQ, I added this health check, okay, a test called RabbitMQ diagnostics ping, okay, simply pinging it with these following intervals, okay, so that the order service finds RabbitMQ ready. And that was the only trick. Yeah, something small, but it really helps us. So if we go to here on the documentation and then click this and click try it out and try putting an order ID and a user ID, okay, and then execute, you see, yeah, says order received and is being processed in the background. Now when I go to RabbitMQ, okay, and refresh, okay, now if I go to, of course you can see there's a connection. If I go to maybe queues and streams, I'm going to show you something. When I was testing, I of course came here to the queues and I saw no queues available and I was wondering why. And when I went to the code, I discovered I was publishing to a queue which has not been declared yet. So up here, I said await channel dot declare queue order events. So yeah, this is very key. We're publishing to a queue which does not exist. So now if I go back here and try to execute this again and come back here and probably refresh the page. Wow, nothing yet. It says 0 queues. I thought about it closely. I hadn't rebuilt the images, okay, especially the order service. I hope I'm right. So I'll execute this again. So we see, yeah, order message was received. If I come here and we go to queues, okay, now we can see that we have the order events. Okay, yeah, finally, after having to sweat a little bit. So now, like you've seen, I hit our order API using Swagger and I clicked execute. The API responded instantly. And now the RabbitMQ dashboard has a queue called order events. And there's exactly one message sitting inside it and waiting perfectly. Our order service is completely decoupled, but right now the messages will just pile up. So in day 9, we are going to build what is called the saga pattern, and we shall use the new service called the inventory service to listen to this queue to consume the event and reduce the stock automatically. Subscribe and I'll see you there.